Good morning, everyone, and welcome on the Autumn Concrete webinar, focusing on the reinforced concrete frames in application Member. Let me introduce myself. I'm Lucas, and today I will be participating as the speaker. And through the webinar will lead us my colleague Petra. Hello, Petra.
Hi, Lucas. Hi, everybody.
So we are using GoToWebinar platform. So on the right side of the screen will pop up the control panel where you can type in the questions and we answer them. And you are all only in the listen only mode. Let's step up to the agenda. We will discuss about IDEA StatiCa Member, IDEA StatiCa scheme of frame, something we will talk about load effects. We will look on the reinforcement design and also the code checks. So I will pass presenter to my colleague Petra, and Petty, you can start.
Thank you, Lucas. Thank you for a nice intro. So let me switch to or share my screen. So I hope you can see the agenda. So let's proceed. So today we will focus on IDEA StatiCa Member Beta. IDEA StatiCa Member application is a new app which was released 2 weeks ago as a beta version. So it is still in development, and I encourage you to ask questions or proposals during the webinar and become part of its development. IDEA StatiCa Member is available for all users who have ever purchased a concrete license of IDEA StatiCa. So don't hesitate to test it and go through it. Why have we developed it, or what does a member do? So the answer is very simple. We want to unify all IDEA StatiCa apps into one application, improve the UI, make the inputs simpler, definitely integrate the member into your CAD and FIA software, and most importantly, we want to implement more advanced analysis. So that's the highlights of this application or our plans. And I would like to start the poll and ask you about your idea or opinion. So Lucas, could you please launch the first question of our polls?
Yes, I did it. So the poll, the question is, do you like the imagine unifying of all IDEA StatiCa apps into one application? And the choices are, yes, I will definitely prefer to use one application for ETH. Rather, yes, but sometimes I want to use standalone application. Probably not, but sometimes I would use as unified solution. No, I prefer standalone application. Please, you can vote, and I will show up after that the results. Okay, I will give you 10 seconds. And okay, close it up, and I will share the results. So the most frequent answer was yes. I will definitely prefer to use one application for ETH. 56%, and B, rather yes, but sometimes I want to use standalone application. Thank you for your voting, and I hide the polls, and Petty, you can continue in your presentation.
Okay, so thank you for the votes, and please stay active and ask the questions during the webinar, and we will answer them right now or maybe later via email. So by this slide, we are entering the practical part of this webinar. Today, we will focus on reinforced concrete two-story hull structure and especially on this frame. Imagine that this frame is somehow critical for the whole structure and we need to investigate it. And we will do it in IDEA StatiCa Member. So let me switch to IDEA StatiCa. You can run the application from the home page of IDEA StatiCa here, or if you go to Concrete tab and choose the Member application. We will create a new project together and do some settings at the beginning. So first of all, I will name this project, for example, frame webinar. You can select where the project will be saved. And important thing, it is important to switch from steel environment to concrete one. As you can see in the scene, there is a steel member. How to do it? I will go to cross section, click on this arrow and assign a concrete cross section to the member. So you can choose from basic or advanced sections. Let's select rectangular cross section 500 millimeters high and 250 millimeters wide. Of course, the concrete class can be defined here. We have a C2530. If you need to change it, you can select from the known library of the material. I click OK. So you can see that here we have a concrete member, and the last step is to select from the right template. We are going to model a frame of a general geometry, so we will select this third option. I got these two tables, nodes and members, so I simply define the coordinates and connectivity of the nodes, which will define the members. So the coordinates are as follows. Click another row, 6 meters, 3.6, and fourth node 6 meter 0. And in this second part, I will define the members. So now we have a beam, and third member will be the column. I can quickly check if the geometry is according to my desire, and if it's okay, I can create a project. We obtain this frame consisting of 3 analyzed members. At the beginning, it is important to switch to right member type. So at the property window, I need to change the settings from B to column because it is a column. The second analyzed member is beam, and the third one is again column. Then we can proceed with the settings of the support. So I will switch from solid view to transparent one. You can see the names or labels of the members, and here at the bottom there are supports. The supports are hidden in under the connection and in connection 1 and 4. I need to fix these ends, so I will change the settings of this support. You can see that the mark has changed. The same I will do for the node number 4. So I will define a fixed end of this column. Right now the geometry is complete and I can move further. And the second part is to define the loads. The loads are here under load effects. They can be added by this button on new, or we can simply modify this default first load effect. Analyzed members are always subjected to line loads. Line loads can act on the member, on the whole length of the member, or on the part of the member. So for example, if I defined just the part from 1 to 2 meters on analyzed member 1, I changed the uniform load to load acting on this part only. For these cases, we will use the line loads acting on the whole length. So I will change it back, and right now I will modify the values. Before that, I would like to explain what is the check type here. It says what type of combination is it, or are these values here. So if I choose ULS, it means that these values stated in this table correspond to combination values, or let's say factored values. So, or we can also call them design values. So the first combination will be for assessing the ultimate limit state, and let's change these values to the real values, which correspond to loading effects from the global analysis. So the first value represents the dead load on the column. Then we need to define some wind load. Then I go to MA2 and change the value here. And the same will be done for the third member. Actual loads, and this time no wind load. So this is or these line loads represent the combination values, the combination of dead load and wind load. I can copy these load effects, clicking by copy button, and create another combination. This time it will be serviceability limit state assessment characteristic combination. So let's change these values. These values will be slightly lower since it is a characteristic combination. Notice that these signs are always related to the local coordinate system of the member. on labels, I can activate local coordinate system and check the direction of the local axis. So let's finish these values, -813, and here there will be the same value as here in MA1. And then I will copy LA2 and create the third combination representing quasi-permanent one. And here we just need to remove the part of the wind load because it's a quasi-permanent state, and we are supposing that there is no wind in this combination. So that's the definition of the loads. And now we can go to third part, and that would be reinforcement design. How to design the reinforcement? It's very simple. Click on Analyzed Member and click Rebar. Those of you who use RCS application of IDEA StatiCa probably know this dialog. It's a reinforcement editor, and by means of this editor, we will simply define the reinforcement in each of analyzed member. Since we define the member type as column, there are column templates available. Templates for reinforcement. So I will use it because it's very fast, and define the numbers and diameters of the longitudinal bars and stirrups. So let's have 14 millimeters diameter in the corners, then some additional reinforcement 8 millimeters, and stirrups will be also 8 millimeters, distance 200 millimeters. I click OK. You can also define the cover here. Let's have 30 millimeters. If I click on the group of bars, I can change the diameters. I can change the spacing of the stirrup. I click OK, and I just reinforced analyzed member 1. I will do the same for MA2 and MA3. This time it's a beam member, so we have a little bit different reinforcement templates, and let's reinforce it similarly as the column. So 14 millimeters diameter will be the main reinforcement, and then we have stirrups 200 millimeter distanced. I click OK, and let's reinforce the last member. Click OK. So this is very fast. So and we can play with the reinforcement layout. For example, if I click on the stirrups on the beam, I can specify different spacing by this description. So that means that first 10 stirrups will be 100 millimeters spaced, and then we will continue with 200 millimeters, and then at the end of the beam, the same 10 times 100 millimeters. And this description or prescription can be even more complicated. I can also define so-called non-continuous longitudinal bar. This is done by reinforcement zones in a property window. So I will create 3 zones. I can use relative or absolute dimensions to define the zone. So let's stay with relative and divide the beam for 3 parts. I will click on the first part, go here to this preview of the section, and click on the middle bar. the color has changed, and you can see that this bar disappeared. I will do the same for the third part. So you can watch this part in the scene, and I will click on the middle bar, and that's how we simply define non-continuous beam, which is here just for the sagging moment. So reinforcement is defined, and we can calculate the internal forces. A linear analysis was performed. I will click on transparent view again and click on internal forces. By this button, I can check out the distribution of, in this case, bending moments for LE3 for the quasi-permanent state or combination. So let's choose ULS combination and, for example, shear forces in Z direction. Or I can change the view and see the all values. For example, bending moments. Sorry, this is none, and this is for the each section. Last part to do is to code check this frame. So we go to check tab. We have the results, so we can code check the internal forces. So I click on a section check button, and RCS application will launch. Again, those of you who use this application, you know that RCS application is an application for code checking of sections. So here we have the list of our critical sections. The first two are for the column, and these 2 to 6 are related to beam member. It depends on the zones, on the reinforcement zones, and that's why we have more sections for beam member. But we could also define the same zones for the column member. You immediately see the status of the checks. So you can see that there is something wrong with at the column check. At this summary section check, you can see that we have a problem with detailing. So I choose this section. There are 3 extremes. Go to results and look at the detailed results. And in detailing, I can see that not okay is the distance of the stirrups. So I use 200 millimeters, but the maximum value is 160. So I should go back to member and redefine the reinforcement. Let me switch to sections again and show the results for a beam. So for example, I will use the middle section of the beam, click on the results again, and show the detailed checks like bending moment and normal, or interaction of bending moment and normal force, shear check, interaction of bending and shear, stress strain distribution along the height of the cross section, and there are other checks relating to serviceability limit states. For example, this is a stress limitation and crack width. So I will close the RCS, and I could proceed in design like changing the reinforcement, or maybe change the cross-section because you could see that there were some reserves. How to change the cross-section? So if I click on Analyzed Member, I can click on this pen and, for example, define lower value, lower height. This is automatically changed on each member because we use the same cross-section for all members. But if I need to change the dimension just for the, let's say, beam member, I will click on this plus button and define a new cross-section. And then I would continue with calculate and go back to RCS. So this is the end of the first part of this example. Now I will switch to presentation, and I decided to show you different, or let's say more advanced workflow, how it is possible to design and co-check a reinforced concrete frame with adjacent parts of the structure, including so-called related members. So first of all, why do we use them, or what is the meaning of them? So I will go back here to the global model of this two-story hall structure, and I would like to explain the meaning of the related members. So if we have this reinforced concrete frame, we would like to take into account the constraints of these related members. Why to do it? Because then by that we can capture more realistic behavior of the structure and substitute the missing part of the structure, because in the member we have only this frame. So in a minute I will show you how to model and subject these related members to load effects. So I prepared this frame, we know this example, and switch to transparent view. And right now I will show you how to add the related members. You can see that under the related members there are no members. So we need to go to the particular node and add the related members. So as it was seen in the presentation, the related members will be on will be added on node 2 and 3. So I go to cone 2. Here we can also change the coordinates, define the supports, and add related members, either ended or continuous. In this case, I will choose continuous bar in Y direction. You can see that there is a RM4 related member, and I can change its dimension. So I know that the related member will be 5 meters long on each side, and this will represent the missing part of the structure, of the whole structure. I won't use support, so I will uncheck these checkboxes. Notice that cross-section is the same, 500-250 rectangular, but we can also change it. In this case, it has the same cross-section like the analyzed members. Then I go back to cone 2 and add another related member in Z direction. This time it will be ended member, no supports, and I will use the right coordinate. And now we will do the same for cone 3. So continuous member in y direction, -5 meters. Again, I will remove these supports and go back to cone 3 and add member at z direction, the same dimension, and last member is in x direction. We'll change the dimension and remove supports and leave here just the support in a z direction. So this is how we create the related members. And now I will switch to different project because we do not have much time left. And I have already prepared complete model. So I would like to comment how to work with related members. So let's stay in load effects 1. Again, we have a factored load here. I have showed you how to apply line loads on analyzed member. But in this table, if the related members are defined, it is possible to subject them to line loads too. So RM4 to RM8 are subjected to a dead load and also wind load. All loads are taken from the global model. What is the global model? I will go back to the presentation. So imagine that this is the global model of the whole structure. We analyze it and we will get some results. And these results can be applied also here via end forces on related members. What is the purpose of these end forces? So these end forces are visible at the ends of the related members, and they are here to influence the diagram of internal forces in such a way that it is identical to diagrams on global model. So it means that if I apply the forces at the end, I do not need to use the supports, and I am able to influence the, for example, distribution of bending moments. So right now it looks like same like it would be done in the via global model. What is the or the meaning of the related members become more obvious once we implement more advanced analysis in the member, because advanced analysis are time consuming and require higher calculation capacity. That's why we only analyze critical members or just a part of the whole structure. And now or once it is implemented, it will be really beneficial to calculate only the analyzed members and not, for example, not calculate the whole structures, because it would take years. Another explanation for related members is that this or such a model is already prepared for integrating the FAS software. So you will just choose the critical part in a FAS software, and it will import all loads or effects of the related members on the analyzed member. So the analysis become more realistic, and of course the code check could be safer and more economical. So I think that this is end of the practical part, and I will pass the presenter to Lucas, who prepared another poll for you. Is that right, Luki?
Yes, of course, Petty. So I will share another poll.
Okay.
Okay, now I'll do it now. So let's do it. The question is, what functionality is your priority? Choice 1 is members should be linked to FEA software like SAP 2000, Robot, many more. The second answer will be member should be linked to the CAD softwares, Tekla, Revit, Allplan, and many more. The other, more advanced types of analysis available implemented in member. And the fourth one is tuning up the UI and improve inputs. So please vote, and I will display the results of your voting. So, okay, I'm convinced that you are done with your voting, and I will show up the results. So most of you would like to member should be linked to FEA software, the first answer. 36% is for choice, let's say B. Member should be linked to the CAD softwares, Tekla, Revit, or Allplan, and 14% more advanced types of analysis. So thank you for your answers. I will hide the poll and pass the word to the Petya if you want to continue. So
Now I think that's all from my side.
okay.
So I believe that now is the time for the questions from
Yeah.
our audience.
Okay, so I will take a presenter. I will take a presenter. Okay, sorry. Yes, questions. Yes, we've got a couple of questions, and I will give you one of them. Can we put some point load on the member or some member in the application member on some beam? Is it possible to do it?
So I will answer it. Point load, it is not possible to apply a point load, but you can apply it via line loads, and this line load can be defined on the part of the member. So for example, you can distribute the point load to specific width, let's say half of meter, and this line load acting on a half of meter can represent the distributed point load. We also got this question in the release webinar, and I think I've shown it there, so you can check the release webinar as well.
Okay, super Petty. Thank you for your answer. And I have also the second one. Is it possible to make the opening in the beam in the application member?
So far it's not possible, but once we implement the solver from IDEA StatiCa detail, it will be possible to model it and also analyze it, including the opening. So you can look forward to it.
Okay, thank you, Petty. So we don't have enough time for the next question. We will answer it after webinar. So please don't leave and make a short survey after closing this webinar. Please make a short survey, and the recording will be posted and delivered to you via email till 3 days. If you are newbies, you can get a free trial on our webpage, ideastatica.com, and all the informations and materials, tutorials, research papers you can find in our support center. You can looking forward on the upcoming webinars. The first one is Connection Wednesday. It will be on the real structure from the UK, I suppose. It will be in November, and in December you can looking forward on the next and upcoming webinar for concrete part. So that's all from our side. Thank you for joining us, and enjoy the rest of all day. Bye bye.
Bye bye. Have a great day.